So here we have an example of a basic algorithm. Suppose that I've given you a problem, write an algorithm to get the sum of 5 and 10. Display it as result. So the algorithm for this, so we will just write it step by step. So I want you to use this kind of format wherein we have step 1 and then step 2, step 3 and then step 4. So each step has their own instruction. So step 1, this one is the starting point of our algorithm. So that's why we always put start on our step 1. The next step, which is step 2, we have to get the sum of 5 and 10 using addition operation and assign it to result. So here we don't have to declare or create a variable for 5 and 10 since it's just only a constant value that we need to add, which is 5 and 10. And also you could put the instructions, or let's say on how to use the addition operation below the step 2, just like this. So 5 and 10, so 5 plus 10 is 15, and the result of this would be assigned to result. And then step 3, display result. So actually result is a variable, so anything that could be assigned to it will be displayed in step 3. And then after step 3, we have step 4, which is stop, meaning to say that this algorithm has finished. Okay, now here's an explanation for example 1. So step 1, it serves as a guide on where should the reader starts the algorithm. And then step 2, it states that in the problem, we need to get the sum of 5 and 10. This is where we put the process to be taken and how to do it. Just take note, class, that it's not always in step 2 wherein we put the process of to finish this algorithm. Okay, sometimes we put it on step 3 or step 4 depending on the implementation of that problem. Next is step 3. It shows the result as output of the process since it states in the problem that the sum should be displayed. Okay, and then step 4 is where the algorithm stops. So that's it. Now, how about if I ask you that uh, we should also add other numbers. Instead of just 5 and 10, our algorithm should also be able to get the sum of other values or other number. Okay, so with that, in order to achieve that kind of solution, we need to use a variable. Okay, so to have a formal definition of that problem, here's the a problem that you have to solve. So write an algorithm that gets the sum of two numbers as input from the user and display the result. And here's the algorithm for that. Step 1, start. Step 2, declare variables num1 and num2. So num1 and num2 are variables and it will hold the numbers entered by the user. Okay, so num1 and num2 that will hold the user inputs respectively and result that will contain the sum of these variables. Okay, so this num1 and num2, you could change its name depending on your data that will be inputted. Okay, so num1 and num2 will hold numbers, so that's why I named it num1 and num2. Okay, next, step 3, assign numbers to num1 and num2. So you do not have to explicitly put it here. You just need to imagine what would be the number 1 and then number 2 in your head. Okay, so I would assign num1, let's say for example 10, then num2 is for example 15. Okay, next, step 4, get the sum of these variables and assign it to result. So as you can see here, I also put the equation on how to get num1 and num2 and their result. Okay, so num1 plus num2, I'll just plug in the values of 10 and 15. So 10 plus 15 is 25 and it will be assigned to result. Okay, so result here will be displayed in step 5. So whatever the value of result will be displayed in step 5. And then after step 5, step 6, we have to stop the algorithm. Meaning to say, already finished its job. Okay, so this is how you use variables. Okay, so in step 2, we declare or create a variable. So it's just like in your high school or senior high school days, wherein you declare variable in math. For example, let x is equals to 5, and then let y is equals to 10. So x and y are variables. And then in step 3, we will assume that numbers were assigned to our variables. So let's say num1 is 10, and then num2 is 3. Okay, so you can think of another number to assign to those variables, since we're just assuming values to try if the algorithm really works for every input. So class, again, take note, we do not explicitly put those values assigned to those variables in our algorithm. Okay, it's just in your head. You just need to imagine that these variables were assigned with some sort of numbers. Okay, next, step 4. In this step, we will carry out the process to be taken in order for us to get the value or the result or the output. So remember that we need to assign the answer to a variable called result. And to do that, we just need to follow this formula. So result is equals to num1 plus num2. And we all know that num1 is 10 plus num2, which is 3. So 10 plus 3 is equals to 13, and it will be assigned to our result. And then in step 5, we just need to display the result. So whatever the value of the variable result has yield after the process, and that would be displayed on our algorithm. So if we assume that 1 is 10 and num2 is 3, then after the algorithm, result should be 13. And then in step 6, it stops or ends your algorithm. So that's it. Now, so here's an exercise for you. So try this. So if you want to try this, you may pause the video and then challenge yourself, make a solution for this problem. Okay, so let's try to answer this algorithm. So first step, start. And then step 2 says here that declare variable num that will hold the number. Again, class, you have to analyze the context of our problem. It says here that write an algorithm to find out if a given number is even or odd. So meaning to say, we just need to identify a single number. That's why we only declare variable num as a single variable. Unlike in our previous example that we need to add two numbers, that's why we declare or create two variables. This time, we just need to create or declare a single variable, which is num. Okay, step 3, you just need to assign a value for num. And again, class, you just need to think of it. You just you don't have to explicitly put it here, the value of num. Okay, so for example, I assign, let's say, 5 to our num. So I do not put it here. Okay, I just imagine that num was given a number of 5. And then step 4 says here that divide num by 2 and check if the result is a whole number. If num divided by 2 is a whole number, then num is even. Otherwise, it's an odd number. Okay? So for all even numbers, class, if it's divisible by 2, meaning to say the remainder is equal to 0, or let's say the result is a whole number, meaning to say that's an even number. Otherwise, it's an odd. Okay? So since 5 divided by 2 is something like 2.5, so it's not a whole number, it's a fraction or decimal number. So that's why it's an odd number. Okay, let's assign a value for num or another value for num. Let's say for example 8. So 8 divided by 2 is 4. So it's a whole number, meaning to say 8 is an even number. And then step 5, stop. Now the question here is that, do we have to display even or add? An obvious answer is no. because as you can see here in our problem, write an algorithm to find out if a given number is even or odd. It doesn't state here that we need to display if that's even or odd. We just need to identify if that's even or odd. So that's why I didn't put here display odd or display even. Okay? So that's something that is tricky when you are formulating your own algorithm. You need to analyze and understand the context of the problem before creating an algorithm. Okay? So here's another example, class. It says here that write an algorithm to find and display the largest among the three different numbers entered by the user. Okay, so here's the solution. It states here the step 1 is start, step 2 declare variables num1, num2, and num3. So there are three variables because in our problem it says here that we need to find and display the largest among the three different numbers. So three different numbers. So we need a container for those three different numbers. So we don't know yet about those numbers, so that's why we created a variable. Okay, num1, num2, and num3. So it will hold the user's input. Step 3, assign a value for num1, num2, and num3. Again, class, you just need to imagine what are those values. You don't need to explicitly put the value of num1, num2, and num3 here. Okay, so I would assign a value for num1, let's say 1, num2 is 2, num3 is 3. Okay, so check. Step 4, compare the value of num1 if it's greater than num2 and num3. If yes, display num1 is the largest. Since num1 is 1 and num2 is 2 and num3 is 3, definitely num1 is not the largest value. So if that's the case, we will move on to the next step, which is step 5. So compare the value of num2 if it's greater than num1 and num3. If yes, display num2 is the largest. So num2 is greater than num1, but it's less than num3. So that's why we will just proceed to the next step, which is step 6. Now, in step 6, we compare the value of num3 if it's greater than num2 and num1. If yes, display num3 is the largest. Since num3, or the value of num3 is 3, the value of num2 is 2, so num3 is greater than num2, so num2 is out. So num3 is greater than num1 since num1 is just 1, so num1 is out. That's why we will just display num3 is the largest. So after this class, we have to stop the algorithm. Okay, so that's one solution for this algorithm. Okay, class. So it seems like our solution to that previous problem solves the this let's say set of inputs. For some certain inputs, it's actually fast. Okay. However, what if we have these three values? Let's say num1 is 100, num2 is 20, num3 is 30. Okay. So if we look at this algorithm, so again, declare num1, num2, and num3 that will hold the user's input. And then step 3, assign a value for num1, num2, and num3. Actually, these three numbers are already assigned from our problem. Okay, so it says here that num1 is 100, num2 is 20, num3 is 30. So imagine that these are the numbers that we assigned. Next, compare the value of num1 if it's greater than num2 and num3. If yes, display num1 is the largest. So num1 is 100. So is 100 greater than num2, which is 20? Definitely yes, 100 is greater than 20. Now, if we compare num1 to num3, so num1 is 100, is it greater than num3, which is 30? Definitely yes, 100 is greater than 30. Now, at step 4, it will display num1 is the largest. So that is correct, right? But the algorithm doesn't start there. It will continue to check if num2 is greater than num1 and num3 And at step 6, it will continue. It will compare num3, is it greater than num2 or num1, until it stops. Okay? So there is an extra operation, though we already know the answer. Num1 is the largest. But here, in our algorithm, it doesn't stop there. Okay? Since algorithm is in sequence, we have to follow these steps even though we already know the answer. So that's one problem or optimization problem that we need to resolve. Actually, class, there is a since we're creating this algorithm, uh, we can make solutions based on our assumption. Okay, so we can add more steps or extra steps for those numbers. Okay, for example, in step 4, after displaying num1 is the largest, we can proceed already to step 7. Okay, so we will proceed to step 7. It will jump to step 7 and it will not go to step 5 and step 6. Okay, so in step 5, we have to proceed to step 7 after, let's say, if num2 is greater than num1 and num3. Okay, so it doesn't have to check if num3 is greater than num2 or num3 or num1. Okay, in step 6, actually, we don't have to uh, add proceed to step 7 since after step 6, it's already step 7. Okay, so class, actually, we could also optimize this. After proceeding to step 7, so we added those additional instruction for those steps, step 4 and step 5. We could still omit some instructions here. Okay, so compare the value of num1 if it's greater than num2 and num3. If yes, display num1 is the largest, and then proceed to step 7. Okay, so let's say, what if num2 is 200? Okay, so num2 is 200. Now compare the value of num1, which is 100, if it's greater than num2, 200. Okay, so since here we have 200, or num2 is 200, so we will not display num1 is the largest. Okay, so we will proceed to step 5. So compare the value of num2 if it's greater than num1. Okay, so since in step 4 we already knew that num2 is greater than num1, or num1 is not displayed as the largest value since it's either num2 or num3 is greater than num1, so we don't have to compare num1 to num2 in step 5, since if num1 is greater than num2, so definitely it would display num1, but since it's not, so we don't have to compare num2 to num1. Okay, so we'll just omit this extra step. So just remove this. Okay, so compare the value of num2 if it's greater than num3. So if yes, display num2 is the largest and proceed to step 7. So this is correct. Next, step 6. Compare the value of num3 if it's greater than num2 and num1. If yes, display num3 is the largest. So if I'm going to remove this, so I'm going to remove all of this. Okay. And then also this. And just leave display num3 is the largest. Actually, class, we will not be able to go to step 6 if num1 or num2 is the largest. So definitely there's no comparison needed for step 6 since step 4 is already rejected, step 5 is already rejected, num1 and num2 is not the largest. So num3 is the largest, obviously, if we go through step 6. Okay, so display num3 is the largest. And then after step 6, then it stops. So for example, the given is 300. Okay, num3 is 300. So compare the value of num1 if it's greater than num2 and num3. Since num3 is greater than num1, so it would not display num1 is the largest. So after step 4, we'll go to step 5, compare the value of num2 if it's greater than num3. Since num3 is 300 and num2 is 200, so we will not display this num2 is the largest. Okay? So after this, since num2 is less than num3, we will proceed to step 6. So step 6, it just displays num3 is the largest. Okay? We will not achieve step 6 if num2 is the largest or num1 is the largest. Okay? So after step 6, we go to step 7. Okay? So if you have any questions or if you are confused about this, you could just PM me on my messenger. Okay? Next, so here's another approach for finding the largest value among the three different variables. So again, class, as I have said in our definition of algorithm, it can be done in many ways. So meaning to say, one problem can be solved in many different ways using algorithms. Okay, so here's another solution for that kind of problem. Okay, actually we have different categories of algorithms. So we have searching algorithms, sorting algorithms, insert algorithms, update algorithms, and delete algorithms. Okay, so for now um, we will just look for the search algorithms. Okay, so we have search algorithms here. So search algorithms or algorithm to search an item in a set of data. Sort, so algorithm to sort items in a certain order. So let's say alphabetical order, ascending order, descending order, or any order that could be used in an implementation. Okay. Next, insert. So algorithm to insert item in a set of data. Update an existing item in a set of data for update algorithm, and then delete for deleting in an existing item from a set of data. Okay, so we will just have a look of this algorithms on our next topics, or let's say in our programming topics in Python. So you will be able to appreciate these algorithms once we start coding using Python. So for now, we will just look at the search algorithms. Okay, so searching algorithms or search algorithms. So they are designed to check for an element or retrieve an element from any list of data where it is stored. So one of the most commonly used searching algorithm is the linear search. Okay, so linear search or sequential search is a method for finding an element within a list. So it sequentially checks each element of the list until a match is found or the whole list have been searched. For example, we have a list of numbers 12, 25, 10, 8, and 6. So in linear search, the numbers are checked one by one. So let's look for 8. Okay, so it would start from the leftmost side of our list. So that's 12. So it will check if 12 is our lookup value, which is 8. So since 12 is not equal to 8, so we will proceed to the next number. Then it would check, is 25 equal to 8? So since 25 is not equal to 8, it will again proceed to the next number. So one by one to the right. Okay, so one step forward to the right. Is 10 equal to 8? So it's still not our number. So it would again proceed to the next number. So is 8 equal to 8? And since 8 is equals to 8, that's the time that it would stop the algorithm and gives us the position where it is located. Okay, so this is the algorithm for linear search. So let's analyze, class. So step 1 is start. Step 2, declare variables x, so the number that we want to locate, n as the maximum number of elements in a list, a as the list containing the elements or numbers, I is equals to 1, So 1 indicates the positioning of an element or initially at first place. Okay, so first number or first place. So that's on the leftmost side of our list. Okay, so step 3, accept a value for x. Okay, so we will assign a value for x or accept a value for x, meaning to say we will assign a number for x. So remember that x is the number that we want to locate. From our previous example, that's 8. Okay, so step 4, so if I is less than or equal to n and x is not equal to a sub I, add 1 to the value of I and repeat until one or both condition becomes false. Okay, so for now, step 4 is very unclear or confusing. Why do we have to check this too? And we will know more about it later on as we go through this PowerPoint. Okay, so step 5, if I is greater than n, display x is not in the list. Else, display x is located at position I. And then stop. Okay, to help us in understanding these steps in linear search, algorithm for linear search, let's use a table and an example list of numbers. Okay, so x is our lookup value. Okay, so it says here that let's locate 5 on this list of numbers. So our list of number is called A. Okay, so list of numbers A. So this is set A. Okay, and then n is the maximum number of elements in a list. So what is the value of n? How many elements do we have on list A? So we just need to count this now. 1, 2, 3, 4, 5, 6. So meaning to say n is equals to 6. Okay? And then next, letter I is equal to 1. Okay? So it indicates the positioning of an element or initially at first place. Okay? So if we combine it as a subscript in our list A, it would look something like this. So A sub 1 is 1, A sub 2 is 11, A sub 3 is 15, A sub 4 is 5, A sub 5 is 8, A sub 6 is 20. So I is actually the positioning of an element in our list A. Okay, so it's like this. Okay, the first element in set A, the second element in set A, the third element in set A, the fourth element in set A, the fifth element in set A, and the sixth element in set A. So just like that. Okay? So going to our table, we have to accept a value for x. So meaning to say this is the lookup value, so that's 5. Okay? So x is 5, and then initially I is equals to 1. Now, so what is a sub I? So a sub I here, so if we plug in the value of 1 to our I, that's 1. And then what is n? That is the number of elements in our list, which is 6. Now, we have to check two conditions here. I is less than or equal to n, and x is not equal to a sub I. Okay? So you will know more why we have to check on this. But there's something that I have to assure you that this is not just this is a experimentation, or let's say a trial and error before we get that kind of condition. Okay, so it's not just you create an algorithm and just in one go you will be able to determine what kind of condition you have to put on your algorithm. Okay, it's not actually the first time that I created this. I test many inputs before I actually have or got these conditions to be included in our algorithm. Okay, so is I less than or equal to n? So what is I? I is equals to 1 and n is equals to 6. So based from our table, I is equals to 1, n is equals to 6. So is I less than or equal to 6? N or 1 is less than or equal to 6, so that is true. And then x, so x is 5. Is it not equal to a sub I? So x is 5. Is it not equal to a sub I. So this is also true. They are not equal. Okay? If that's the case, we have to add 1 to I. Okay? So that's step 4, class. That's step 4. So we check for I is less than or equal to n. So this is true. And x is not equal to a sub I. So this is also true. If that's the case, we have to add 1 to the value of I. So this is it. And then repeat until one or both condition becomes false. Okay. So is I equal to I plus 1? So since I is equal to 1 plus 1, that's 2. Okay? So going back to x, we have to repeat the process. So x is equals to 5 or still equal to 5. I now is equals to 2. And then a sub I. So we need to plug in 2 to the subscript of a, which is I. So a sub 2 is equals to 11. So I'm just referring to this list. So 11. N is still 6. We still have 6 elements on our list. And then we will check, is I, which is equal to 2, less than or equal to n, which is 6. Is 2 less than or equal to 6? Yes or true? Now, is x, which is 5, not equal to a sub I, which is 11? Yes, it's still the number, or it's still not the number that we're looking for. So it's still true. So after that, I is equals to I plus 1. So our current value for I is 2 plus 1, that's 3. Okay? So going back, we will repeat again the process. So x is 5, I is 3, a sub I, so a sub 3 is equal to 15. And then n is still 6. Now, is I less than or equal to n? So I is actually 3 and n is still 6. So I mean to say we're still inside the list. Okay? So this is true. And then is x, which is 5, not equal to a sub I. So a sub I is 15 and the number that we're looking for is 5. So it's still not the number that we're looking for. So we still need to look for the other numbers. Okay? Since I is not yet equal or not yet greater than n. Okay, so we still have numbers to search for. So after that, I plus 1, so that's 4. Now going back to our x, so we still look for 5. So I is equals to 4, and then a sub I is equals to 5. Okay, and then n is still 6. Now, let's check. Is I less than or equal to n? So I is 4 and n is equals to 6. So it's still less than n. This is true. So there are still numbers that we need to search for if we're not able to find our number. Now let's check. Is x not equal to a sub I? So our x is 5. This is the lookup value, and then our current number for in our list is a sub I. So a sub I is equals to 4. So a sub 4 is equals to 5. Is 5 not equal to 5? Okay, so this is false. Once one or both condition becomes false, we will terminate this step 4. So I mean to say we will stop step 4. We're not going to add, or let's say we're not going to check the other numbers, since we already find our, or we already found our number, which is in step 4. So in step 5, we will check, okay, if I is greater than n. So I here is the position of the element and n is the total number of elements. Okay? So the only time that this I is greater than n is if we search already on all the elements of this list and still not find still we're not still able to find our number. So I would become 7. So that's somewhere around here. So this is a null value. Okay, this is a sub 7. It's a null value. We don't know what value is that. And 7 is greater than n. So we already exceed on the number of elements in our list. So if I is greater than n, display x is in the list. So this is the only time that we're not able to find our number, since we already exceeded on the list and we're still not able to find it. Else, if it's not the case, we have to display is located at position I. So we end up here, since x is equal to a sub I, so we end it here. We're not able to add 1 to I, so the ending value of I is 4. Okay, so display x is located at position I, so I is equals to 4, x is equals to 5. If we plug in those values, display 5 is located at position 4. Okay, so after we output this step 5, we need to go to step 6, which is stop. Okay, so I hope that you understand the this algorithm for linear search. Okay, so let's move on to other searching algorithms. We have the binary search. So binary search is a search algorithm that finds a position of a target value within a sorted list. So binary search compares the target value to the middle element of the list. Okay, for example, I've given you this list of numbers: 8, 1, 12, 4, 15, 2, 7, 3. So in order for us to use binary search, so we need to sort them in ascending or descending order. So to make it simple, let's use ascending order. So the ascending order of our list is 1, 2, 3, 4, 7, 8, 12, 15. Okay, so if we have a sorted value of numbers, we will be able to use binary search. So let's say I would like to look for 1 in our sorted list. Okay, so now, as I have said a while ago, we have to check the middle part of this list of numbers. So as you notice, we have a even number of lists. So normally we divide it by 2. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8. So 8 elements. So divided by 2, so that's 4. If this is an odd number, this would be easy to trace what would be the middle value, since it's odd. But for the case of even, we divide it by 2, and then we start on that position. Okay, position of number. Okay, so if this is at the fourth, or the 8 divided by 2 is 4, so we will start at the fourth element in our list, which is 4. Now, we will ask ourselves if is 1 equal to our current value, which is 4. Is 1 equal to 4? It's not. Now, if it's not, we have to ask ourselves again, is 4 greater than or less than 1? So 4 is greater than 1. If that's the case, we will ignore all the numbers that is greater than 4, including 4. Okay, just like this. So we don't have to search this part of the list, which makes our searching easier. After that, again, the remaining numbers will be counted. So there are 3 elements. We will divide it by 2. So that's 1.5. 1.5 or 2. Okay? So we will go here. Now we will check again. We will ask ourselves, is 1 equal to 2? Since 1 is not equal to 2, we will ask again ourselves, is 2 greater than or less than 1? Since 2 is greater than 1, we will ignore again all the elements to the right, including 2. Okay? And then, how many numbers do we have or elements do we have? We have 1. 1 divided by 2 is 0.5 or 1. Okay, we will just round it up. So it's 1. We'll go to the first element. Is 1 equal to 1? And it is yes. It is 1. Okay, so imagine how many elements we just traverse on those elements, 4 and then 2 and then 1 from this set of numbers. So we were able to just lessen the number of comparisons onto our list, okay, by half. So another one is yung jump search. So jump search is a searching algorithm used to find an element in a sorted list of elements. So this is just like a binary search that requires the input of data to be sorted. So but it uses a different approach to find the target element efficiently. Okay, so let's try it also to our previous list of numbers used in our binary search. So we also have the 1, 2, 3, 4, 7, 8, 12, 5. Okay, so again class, just like what I've said a while ago, every problems we can solve it in many different ways. So look at this, we have the same list of numbers, right? But we have different approach to solve it. Now, let's look for 8 in our sorted list. Okay? First, we have to get the square root of 8. So the value inside the square root depends on how many elements are there in the list. So still we have 8 elements in our list. So we just need to get the square root of that number. So square root of 8 is equal to 2.82 something, or just 2.83. So 2.83, we need to round it up to become 3. Okay? So the value 3 is the number of jumps from our number to the next. So we will exclude the jump or exclude our number in our jump. Okay? So here's how it goes. We will start on the leftmost side or the lowest value on our list. So that's 1. Remember that we need to find 8 in our list. Okay? So here, from 1, we will check. Is 8 equal to 1? So it's not equal to 1. So we will jump from our current value to the right 3 numbers, excluding our number. Okay, so excluding our number, so 1, 2, 3. So now our current value is 4. Is 8 equal to 4? It's still not equal to 8. So from 4, we will jump again 3 numbers to the right, excluding our number. So we have 12. Okay, so here we have actually class, you need to also check if the current value, if it's not equal, you have to check if that is less than or greater than. I forgot to tell you. Okay, so sorry. Okay, so you jump to from 1 to 4. Now if 8 is not equal to 4, we will check if 8 is greater than or less than 4. Since 8 is greater than 4, then we will jump again to the right, another jump. So we will check again. Our current value is 12. Is 8 equal to 12? So it's not. Now we will check or ask ourselves again if 12 is greater than or less than 8. Since 12 is greater than 8, so we have to go backwards. Okay, so we will go backwards. We will perform a linear search backwards. Okay, so we will move to the previous numbers one by one. So first step, to the left. So we have 8. Is 8 equal to 8? So it is. So if it's the number that we're looking for, then we have to stop. Okay, so if it's not, we will move again to the next number until we reach 4, which is our uh, the number that we jumped before, and then we will stop our algorithm, and then we will just tell to the user or display that the lookup value is not in our list. Okay, but for the case of this list, we located 8 in our list, which is on the sixth position. Okay, so that's all for now. Thank you for listening. So I hope to see you on our next meeting. Please do not absent. Thank you, class, and see you.